Here given two complex numbers, z1 is equal to root 3 plus I root 3 and z2 is equal to root 3 plus I, and we need to check whether this complex number z1 upon z2 whole power 50 lies in the which quadrant. So consider z1 by z2. So we can write root 3 plus I root 3 divided by root 3 plus I. Root 3 taken common, 1 plus I upon root 3 plus I. Let's consider its square. So root 3 whole square 3 times of 1 plus I whole square divided by root 3 plus I whole square. Let's do separately here. 1 plus I whole square is equal to 1 square plus I square plus 2 into 1 into I, which is 1 minus 1 plus 2I. So that is 2I. Similarly, root 3 plus I whole square is equal to root 3 whole square plus I square plus 2 root 3 I. That is 3 minus 1 plus 2 root 3 I. That is 2 times of 1 plus root 3 I. So we can write here z1 by z2 whole square is equal to 3 times of 2I divided by 2 times of 1 plus root 3I. So which can also be written 3I divided by 1 plus root 3I. And we also know that cube roots of unity 1 omega square for the equation 1 plus x square is equal to 0, where omega square is equal to minus 1 minus root 3I divided by 2. So here we can write 2 omega square is equal to minus 1 minus root 3I, or minus 2 omega square is equal to 1 plus root 3I. So instead of writing 1 plus root 3I, we can also write minus 2 omega square. So I can write here 3 times of I divided by minus 2 omega square. This is z1 by z2 whole square. Now let us consider z1 by z2 whole power 50, that is whole power 25. So z1 by z2 whole square whole to the power 25, which comes 50, which is equal to 3I divided by minus 2 omega square whole power 50. That is 3 power 50 into I to the power of 50 divided by minus 2 to the power 50 into omega to the power 100. And now here I to the power 50. So we can write I to the power of 4 times of 12 plus 2. When 50 is divided with 4, the remainder is 2. So we can consider as I square, which is equal to minus 1, since we know that I to the power 4n is equal to 1. Or I to the power of 4n plus 2 can be taken as I square, which is equal to minus 1. And similarly omega to the power 100, since omega cube is equal to 1, omega power 100 is equal to 100 is divided with 3. So 3 into 33 plus 1. So the remainder is 1. So we can consider omega power 100 is omega power 1, that is omega. So let us write here 3 power 50 divided by minus 2 power 50, we can write 2 power 50 since power is even, into I to the power of 50 is I square, that is minus 1, divided by omega power 100 is omega, and minus 1 upon omega. Or from here we can say 1 upon omega is equal to omega square, or minus 1 upon omega is equal to minus omega square. So here we can write 3 by 2 whole to the power 50 into minus omega square, and we know that omega square is equal to minus 1 minus root 3i divided by 2. Then negative omega square is equal to plus 1 plus root 3i divided by 2. So we can write 3 upon 2 whole power 50 into 1 plus root 3i divided by 2, or we can write 3 by 2 3 by 2 whole power 50 times 1 upon 2 plus root 3 by 2 to the power I. So here we can see that the real part and imaginary part both are positive. 1 by 2 is positive, root 3 by 2 is also positive. So we can consider 3 by 2 whole power 50 is also positive. So we can say that this complex number which lies in the first quadrant. When x coordinate, y coordinate both are positive, a complex number will be lying in the first quadrant. So we can go with an option A, first quadrant.